All right, so to wrap up this unit, or this lesson, I should say, let's do a quick activity on identifying which ones are the differences of squares. And then let's just finish it up by factoring a couple that, let's see what they look like. So remember that to be the difference of squares, you must have subtraction. So let's eliminate all the ones without subtraction to start, which is just x squared plus 16. The other one is you must have squares. Okay, well, let's look at the first one. We have an x squared. Can we rewrite 64 as something squared? Yes, 8 squared. So we can say that x squared minus 64 is 1. What about the next one? Well, I can pull out an x, leaving me with x take away 12. It's factored, but not a difference of squares. What about the last one? Can I rewrite this as x squared take away 1 squared? Well, 1 squared is 1, so that would work. So here's our second one. Here's our second difference of squares. All right, now let's do some factoring. Remember, you can't factor a second degree trinomial if it's not a second degree. So in this one, we have an x cubed. So we pull that out first, leaving us with x squared minus 49. Well, what multiplies a negative 49 adds to 0. You can say that that is x plus 7 times x minus 7. If you didn't see that, if it didn't pop out to you, another way to look at this is let me move something really quick. Another way to look at this, bear with me a second. Okay, is we could have said we had x times x squared minus 7 squared, which then shows you the difference of squares. All right, what about the second one? Second one's a tough one, right? How can we rewrite that one as a difference of squares? Well, can we rewrite 4x squared as 2x squared? Yes. Minus 3 squared. Follow the pattern. Remember that a squared minus b squared equals a plus b. Let me try to actually write like a human. A plus b times a minus b. So we can say that this is going to be 2x plus 3 times 2x minus 3. And the last one, at first glance, the last one does not look like it's a perfect square. But what do both terms have in common? Okay, well, we can pull out a 3, leaving us with an x squared minus 4, which will simplify to 3 times x plus 2 times x minus 2. Okay, so we have them all factored now, but we got to go back because we forgot to do something, okay? Mr. M did read the directions. Solve them. So to solve them, they're all set equal to 0 already, and that's super important to know, okay? Remember the zero product property? If any one of the terms equals 0, the whole thing equals 0. So we can say x equals 0, x plus 7 equals 0 when x equals negative 7. So there's your second one. And then x minus 7 equals 0 when x equals 7. So here's our 3 answers for number 12. What about number 13? Well, when does 2x plus 3 equal 0? When does 2x minus 3 equal 0? For this one, we can say 2x equals negative 3, so x equals negative 3 halves. And then we could say 2x equals 3, so x equals positive 3 halves. And for our last one, there's nothing you can do with the 3, but you can say that x plus 2 equals 0 when x equals negative 2. And you can say x minus 2 equals 0 when x equals 2. So what did we learn in this last one? How to tie factoring into the zero product property. It is a super important skill for you to know. It's something I'm doing with my pre-calc honors class right now. So it's not like it goes away. It's very, very valuable.